Hey, Algebra 1. Guys, welcome to the rip-roaring fun house that is Algebra 1. Okay, that's not true. No, but that's okay. That's okay. We are all going to rock this first section, Chapter 1. Here we go, titled Evaluate Expressions, Use Exponents. Those are some big fancy words. We're going to get to the bottom of it. Here we roll. Okay, everybody, open up your textbook. You should be following with me in the textbook. I'm on page 5. You need to be there too. Okay, let's get rolling. So again, you can pause the video, you can rewind the video, do all that necessary stuff to help you best. Okay, here we go. You will need to copy the chart on page 5, right there at the top. Let's start by doing that. Pause the video, take care of that. All right, you're coming back. You will also need to copy 2 key terms that are in yellow on page 5, and then you have 3 key terms on page 6. Take care of that, okay? So the reason why you got to do these key terms is because in the section, in my lecture videos, and on the test, you will hear these words being used, and you need to know what they mean, okay? So that's it. And then let's get to one of the words that you will hear a lot, the word evaluate. As I say, basically just a fancy word for solve. Okay, so if you see the word evaluate, you see the word solve, just go ahead and use them basically as the same exact thing. All right, so let's move into our first example problem. Let's say you are given 0.4x, and then they say, okay, x is 6. All right, so let's just go ahead and take that 6 and replace the x with 6. So really you're looking at 0.4, and that's going to be multiplied by 6. Okay, so don't forget the basics of multiplication with decimals. So you'll notice we have one number after the decimal. That number is a 4. So if we were to simply take 6 and multiply that by 4, you would get 24, right? Okay, but what we can't forget is that we actually have one number behind the decimal. So we got to take this, move it right there, one number again behind the decimal. So we're looking at 2.4. All right, there we go for example 1. Okay, let's move down the page here. All right, example 2, same exact concept. You got 7 minus x. Well, what is x? X is 9. Let's replace it. You're now looking at 7 minus 9, meaning we will be creating a negative because we have 7, but we're taking 9 away. All right, so in this case, you're just looking at a negative 2. Okay, if you had 7 and you took away 7, you're at 0, but you had 2 more to go. You had 8 and 9, so negative 2. Okay, good deal. Let's keep trucking, get you through this video again, probably as fast as we can. I'm sure you're going to want to move in to the rest of all the Zooms that you have today. Good times. All right, new directions. Write the power in words. That's the first thing. And then as a product. Okay, so let's go one step at a time here. Let's write the power in words. So the first one you have is 7 to the power of 3. Or you could say this is 7 cubed. The point I'm making here is there is more than one correct answer. All right, so you could literally say this is 7 cubed, and you're done. You could say 7 to the power of 3. Literally write that out in words. That's also a correct answer. Now we need to write this as a product. All that means is take the base number, which is 7, and then how many 7s do we have? We have 3 of them. So times 7 times 7. I now see 7 times itself 3 times. That's it. All right, so that's how that one looks. Next one, we have 1/3 to the power of 2, which again, you could literally write out 1/3 to the power of 2. The faster answer, anything to the power of 2 is also known as squared. So this is 1/3. squared. Boom. That's written out in words. Now, what is 1/3 squared as a product? It is 1/3 times 1/3. Now, I want you guys to use parentheses, all right? When you are dealing with fractions and exponents, use parentheses. Here's why. Because if you see 1/3 in parentheses, and then it's to the power of 2, that means that the entire 1/3 is to the power of 2. But what if we lose the parentheses? If we lose the parentheses, then that power of 2 only goes with the numerator. In other words, it only goes with the number on top. Those are big differences, okay? So make sure that we understand that. Moving in here, evaluate, solve, fancy word, all right? So 5 to the power of 3, same thing as saying 5 times 5 times 5, okay? If you want to break this up into groups, what is 5 times 5? 25. Then we still have one more 5, and what's 25 times 5? I believe we are dealing with, let's see, 25 times 5 is 125. Boom. There we go, 125. Okay. Now we have 1/4 to the power of 2. In other words, 1/4 squared. Now that is 1/4 times another 1/4. Okay. And we did a problem very similar to this in our review, the very first assignment. So we're going to go top times top, bottom times bottom. So 1 times 1. What is 1 times 1? 1. 4 times 4, that's on the bottom. What's 4 times 4? 16. There we go. 1/16. Okay. Let's move down. And is it true? It's our last example problem. All right, this is what we're talking about. Let's finish it out strong. Evaluate x to the power of 2, or in other words, x squared. What is x? X is 1.1. So we're going to put 1.1 in parentheses squared. What is this the same thing as? This is the same thing as saying 1.1 times 1.1. All right. Now, how many numbers total do we have after the decimal? Total, we have 2, because we have a 1 right here after the decimal and another 1 right there after the decimal, for a total of 2 numbers. So now let's figure out, technically, if we do 11 times 11, what are you going to get? 121. But we have a decimal, and how many numbers are after that decimal? 2. So take this and go 1, 2 times. So your final answer is actually 1.21. All right. That's it, guys. All right. I would say I hope you enjoyed the video, but you got to learn from the video. All right. So thank you, guys, and we will close it out.